right, in this lesson, we're going to talk about solving rational equations. So a rational equation is a complete mathematical sentence that has equals. Okay, this is different from what we've been working with. We've been working with rational expressions, in which case the only thing we can do with a rational expression is simplify it. Okay, so simplify means we can get it down a little bit smaller. So these three things here will be simplified. There's no equals. Whereas these things here, we're going to actually solve. We're going to figure out what does x equal. So down here when we're solving them, we're going to do something called multiplying by the least common denominator. Now, you have done this before. Back in Algebra 1, you might have seen something small like this. And your teacher would probably have told you that you don't have to sit here and use these fractions. Now, they're not terrible if you have a calculator, but if you didn't have a calculator or if it was a little bit messy, we could actually eliminate these fractions by finding the least common denominator. So we did this in we were adding and subtracting. So here we would say, okay, we need 3 times 7 times 2, which means our least common denominator would be 42. So what we would do is we would take every single term and we would multiply it by 42. So hopefully you recall this from Algebra 1, but if not, that's okay. So here if we do 42 times x over 3, well 3 would go into 42 14 times, so we would have 14x. 7 would go into 42 6 times, so 6 times 2x would be 12x. And 42 times 1/2 would be 21. And notice this is a much simpler problem to solve. So that's what we're going to be doing today, just with a little bit of messier numbers. So we're going to be using rational expressions. Now, the other thing to really keep in mind is that you have to check for extraneous solutions. Okay, this is very important because since there are values that don't work, we have these excluded values. If they end up in our answer, then they're going to be, we have to throw them out. We cannot use them. So looking at this first problem, notice we do have an equals, which means we're solving. We're going to try to figure out what does x equal. We have two fractions. So the first thing we're going to do is we're going to find our least common denominator. So x plus 1 is going to be our first piece. It's already factored. There's nothing more we can do. This second fraction has 4x plus 5. We cannot simplify that down either. So that is our least common denominator. So what we are going to do is we are going to take each fraction and multiply it by this expression. So when we do that, I'm going to leave some space here. So 3 over x plus 1. We are going to take this x plus 1 and this 4x plus 5 and multiply. Now this is on top, okay, so it's kind of like this. And then we're going to do the same thing on the other side. We're going to take this x plus 1 and this 4x plus 5 and we're going to multiply it by 9 over 4x plus 5. Okay, and again, you can think of this as over 1. Okay, so now what's going to happen here is we're going to actually be able to cancel out some factors. So notice here x plus 1 and x plus 1 cancels. We have eliminated the denominator. Same thing here, 4x plus 5 and 4x plus 5 cancels. So what we're left with is we have 3 times 4x plus 5 equals 9 times x plus 1. And this is a much simpler problem to solve because it's linear. So we're going to distribute. So 12x plus 15 equals 9x plus 9. I'm going to subtract the 9x over, get those like terms together. So that gives me 3x plus 15 equals 9. Subtract 15. So 3x equals negative 6. Divide by 3. And we end up with x equals negative 2. Now, before we get too excited, we actually need to go back and check it. That's very, very important. So we're going to check for two reasons. We're going to check to make sure we didn't do anything wrong mathematically. But more importantly, we're going to make sure that this does not end up being an issue in our graph. Now, it really shouldn't be because if I look at my denominators, the excluded values here would be negative 1 and negative 5/4. And that's not negative 1 or negative 5/4. But just to make sure, we're going to check it. So when we check, we plug it back into the original problem. So 3 over negative 2 plus 1 is that the same as 9 over 4 times negative 2 plus 5. So we have 3 over negative 1, 9, let's see, we have negative 8 plus 5, which is negative 3, And last I checked, -3 equaled -3. So this one is correct. We verified it. So that means our answer is x equals -2. And notice here, we're not getting an expression. We're going to get an actual solution for x. All right? So let's try another one, number 2. So again, it's an equals. The first thing we're going to do is we're going to find our least common denominator. So I'm going to make sure my denominators are factored, and they are. So notice 2x plus 5, I need that guy. And then I also need 11x plus 8. So we're going to take and multiply both fractions by this LCD. So 2x plus 5, 11x plus 8, and that's going to be times that 1 over 2x plus 5. Okay, and then that's going to equal, same thing here. We're going to do 2x plus 5 times 11x plus 8, and that's going to be times that x over 11x plus 8. So again, we're going to see what they have in common. Now, if the denominators don't cancel out, then you don't have the correct least common denominator. Okay, here the 11x plus the 8 cancels out with that. So we're left with this 11x plus 8 times 1, which is just 11x plus 8, equals 2x plus 5 times x. So now it's a matter of multiplying it out. Now, this time when we distribute the x, we end up with a quadratic. So in order to solve this quadratic, we're probably going to either want to factor it, or if it doesn't factor, probably use the quadratic formula. So what I'm going to do is I'm going to move everything over. I'm actually going to move it to the right side. So I'm going to subtract the 11x, and I'm going to subtract the 8. Okay, I like my x squared to be positive, but it really won't matter. So 2x squared minus 6x minus 8. Now one thing I noticed is that they have a greatest common factor of 2. So I'm going to actually go ahead and factor that out, or you could even divide it out if you wanted to. But I know that most of the time these are going to factor. Very rarely will they not factor for us at this level. But if you feel more comfortable with the quadratic formula, you can absolutely do that. So now this is going to factor some more. So I'm going to have x and x. Factors of 4 that will add to -3 would be -4 and +1. So that means x has to equal +4, or it could equal -1. Now, we have to go back and check and make sure we don't have any issues with our answers. So when I look up here, now I'm looking at, again, my denominators. Notice that neither of these create a restriction. So this restriction would be -5/2. This restriction would be -8/11. Neither of those have an issue. So I'm thinking they're probably going to work, but if you wanted to check it, and hopefully you would do this on your calculator and not try to do this by hand, what you can do is you can actually store the value. So this button down here, it says STO, S-T-O. If you take the value, let's start with 4, hit that STO button, so again it's right above the on button, STO, and then put it in for x and hit enter. And then what we can do is we can just type in the equation. So we can type in a fraction, 1 over 2x plus 5, and hit enter, and we get 1/13. And then the same thing here, we can type in x over 11x plus 8 and see what we end up with. We end up with 1/13. Since they're the same, they're correct. Now, in order to check the other one, instead of having to type everything in again, we can just say, okay, this time I'm going to store -1. So -1, stow in for x. And then what I can do is I can just go back up here and grab these expressions. And now when I hit enter, notice I get a new value. And that's because they've plugged in -1 this time. So I'm going to check to see if my second equation, my second expression, ends up with the same value, and yes, it does. So I've checked both answers, and they both work. So that means x equals both 4 and -1. Okay, so you can check them by hand or with a calculator. Really, a good mental check is just to see if either of those answers is an excluded value. Okay, that's when they're extraneous. So let's look at number 3. All right, so number 3, this time we don't just have a fraction equal to a fraction. This time we have a fraction plus a fraction equal to another fraction. But the good news is it's done the same way. So we're still solving because this is an equals. The first thing we're going to do is we're going to find our least common denominator. So in this case, we have an x plus 4. we have a 3, so I'll put the 3 in front, and notice we already have an x plus 4, so we don't have to write it twice. Okay, this only occurred one time here, so this one works here as well. So I only need one x plus 4. They already have that in common. So now I'm going to take and multiply every single fraction times with 3 and x plus 4. So 3 times x plus 4 times x over x plus 4 plus 3 times x plus 4 times 1/3 equals 3 times x plus 4 times negative 12 over x plus 4. So every single piece of that equation has been multiplied by the LCD. So again, the denominator should cancel. So notice x plus 4 and x plus 4. Here, the 3 and the 3. Here, the x plus 4 and the x plus 4. Okay, you do want the least common denominator because you don't want to get these too big. They get a little hard to solve if they get too large. So here we have 3 times x. Here we have plus 1 times x plus 4. And over here we have 3 times negative 12, which is negative 36. And this is a much nicer problem to solve because we can say, okay, 3x plus 1x is 4x. So then we have, subtract 4. 4x equals negative 40, divide by 4. So x equals negative 10. And again, I'm going to do a quick mental check and make sure we don't have an issue here. So notice the excluded value would be negative 4 for any of these expressions. So negative 10 is not negative 4. So that means this one most likely works. But again, if you wanted to check it by hand or with a calculator, that would be a really good idea. Okay, so x equals negative 10 is our solution here. All right, number 4. I'm going to let you try number 4. So go ahead and take a minute and pause the video, try this problem, and when you're ready, turn it back on. All right, hopefully you started by finding the least common denominator, which is x times x minus 5. Now, I know this constant here, this 1, could be an issue. Just put it over 1. You can make it a fraction by putting it over 1. So now when we multiply everything by that, we end up with x times x minus 5 minus 8x equals 3 times x minus 5. So when we multiply it out, we end up with x squared minus 16x plus 15 equals 0. Which again, you can either factor it if it factors, and this one does, or you can use the quadratic formula. So when I factored it, I got 15 and 1. So hopefully you got that. If not, make sure you get that written down. But again, we're going to go back and check. So looking at the denominator here, my excluded values would be 0 and 5. Neither of these are 0 or 5, so that's a pretty good indicator that they are not extraneous. Now again, I've already checked mentally, and in my calculator, you should have checked as well just to make sure it's not correct. Okay, all right, last one, number 5. So number 5, we're going to see an extraneous value in this one. So let's take a look at it. So first things first, notice our denominators have a little more going on. I'm going to have to factor this expression here. It is not completely done, okay? So I'm going to go ahead and do that. So I'm going to have 5 over x minus 3 equals, and I'm going to leave some room because I don't have to write this twice, 8x squared. Now x squared minus 9 would be x plus 3 times x minus 3. And then minus, we're going to have 4x over x plus 3, and that's already factored. So now that we have everything factored, let's think about what our least common denominator would be. So our LCD, well, we need an x minus 3. Right? Well, we've already got an x minus 3 written down, but we need an x plus 3. Well, and that one's already got an x plus 3. That's all we need is those two. The only time you write the same thing down twice, like the only time you put x minus 3 and x minus 3 is if this was like x minus 3 squared. Okay, if two factors occur under the same fraction. So that doesn't happen here. So we're going to take and multiply each fraction by x minus 3, x plus 3. X minus 3, x plus 3. So each of those factors, x minus 3, x plus 3. So when we do this, notice again how nicely our denominators cancel out. So we are left with, we're going to have 5 times x plus 3 equals 8x squared minus, I'm going to move that 4x to the front, I like those in the front, times x minus 3. So now let's clean it up. 5x plus 15 equals 8x squared minus 4x squared plus 12x. Be careful of double negatives. So this is a quadratic, so let's get it a little bit cleaned up. So this right here would be 4x squared plus 12x. Let's move everything to the right side. So that's going to give me 0 equals 4x squared plus 7x minus 15. Now you might be thinking, Miss Miller, that doesn't look like it factors. It actually does. But again, if you have having trouble factoring it, use the quadratic formula. But it will factor. So it's going to factor, remember factors of 4 are 1 and 4 and 2 and 2. Factors of 15 are 1 and 15, 3 and 5. So let's see, I think if we're trying to get 7, maybe a 4x and an x. Let's try that. And then maybe a 3. So if we get 12 minus 5, so 12 minus 5, that would give us 7. So negative 5x plus 12x is 7x, negative 15, positive 4x squared. So what this means is we have 4x minus 5 equals 0, and x plus 3 equals 0. So over here we have 4x equals 5. So we have x equals 5/4, and over here we have x equals negative 3. So we have two answers, but if we go back to our original denominators, notice our excluded values would have been 3 and negative 3. 3 and negative 3. Negative 3 can't work in this case, which means we have to completely cancel out this answer. This is an excluded value. So this guy right here is excluded. Sorry, we call him extraneous. He's an extraneous solution, but it's because he's an excluded value. So we don't include extraneous solutions in our answer. Now 5/4 is okay because the answers we couldn't use were 3 and negative 3. And I think if we checked it, it would definitely work. And it does. So 5/4 is going to be our solution.